Short channel effect in Mosfet. What is short channel effect? Short channel effect are a series of phenomena that takes place when the channel length of the Mosfet becomes approximately equal to the space charges regions of the source and drain junctions with the substrate. Short channel effects occur when the channel length is the same order of the magnitude as the depletion layer width of the source and drain junction. In MOSFETs, channel length must be greater than the sum of the drain and source depletion widths to avoid edge effects. Otherwise, the number of effects appear. They are these are the short channel effects that occur: drain induced barrier lowering, channel length modulation, velocity saturation, punch through effect, hot carrier, threshold voltage roll off, subthreshold conduction, mobility degradation. Drain induced barrier lowering. It is a short channel effect in MOSFET referring originally to a reduction of threshold voltage of the transistor at higher drain voltages. In a classic planar field effect transistor with a long channel, the bottleneck in channel formation occurs far enough from the drain contact that is electrostatically shielded from the drain by combination of the substrate and gate. And so classically the threshold voltage was independent of drain voltage. Here you see this diagram. In this, as the channel length decreases, the barrier to be surmounted by an electron from the source on its way to drain reduces. Barrier lowering increases as channel length is reduced even at zero applied drain bias because the source and drain form PN junctions with the body and so have associated built-in depletion layers associated with them that become significant partners in charge balance. The term DIBL has expanded beyond the notation of simple threshold adjustments, however, and refers to a number of drain voltage effects upon MOSFET IV curves that go beyond description in terms of simple threshold voltage changes as described below. As channel length is reduced, the effect of DIBL is subthreshold region show up initially as a simple translation of the subthreshold current versus gate bias curve with change in drain voltage, which can be modeled as a simple change in threshold voltage with drain bias. The ABL also affects the current versus drain bias curve in active mode, causing the current to increase with drain bias, lowering the MOSFET output resistance. This increase in is additional to the normal channel length modulation effect on output resistance and cannot always be modeled as a threshold adjustment. Here you can see this graph which is drawn for lateral position versus surface potential. In this between 2.5 to 0.25 and 0.3 there is the barrier lowering, and after the 0.35 the curve reaches its peak. Here is the ways to reduce the drain induced barrier lowering. By increasing the substrate doping concentration, we can reduce the drain induced barrier lowering, reduce oxide thickness, halo doping. In a MOSFET, there are two primary methods for lowering the threshold voltage: reduction of channel length and reducing the oxide thickness. And thank you.